Now let's start building out the interface for our cryptocurrency exchange. And we've got our smart contract built to manage the exchange, and we've got a token deployed to the network. So now we want to build an interface that's going to connect to it. Just to give you an idea of where we're headed, here's the completed project that we're going to build. So this is the interface for our DApp token exchange that we just built the smart contracts for. Here's where we can deposit our balances and withdraw them. We can deposit Ether and tokens. We can also withdraw them, right? We can see our balances, how much is in our wallet versus the exchange. We can create a new order. We can buy or sell, right? And we can see the order book here. We can click on an order to fulfill it. We can see the price chart, which we'll actually build out later, and our trades and our orders, and also the completed trades for the entire exchange. And all this is real time. It'll update in real time, which we'll see later as well. So also, here's our connected account, right? So there's a lot to do here, but I'm excited to get started. And we can build all of this from scratch. I'm going to walk you through it step by step. So let's jump in and get started. Make sure that you've got Ganache running. Right, so in the last video of the smart contracts section, we deployed the smart contracts to Ganache and we ran the scripts. So if you ever restart Ganache, you need to redeploy your smart contracts. You can do that in your terminal with truffle migrate -- reset, right? And also you can run the scripts in order to put data in the smart contracts. So you can do truffle exec scripts a seed exchange, right? That's one of the reasons I created the script, is so that every time you restart Ganache, you can add new data to your smart contracts. And whenever we deploy the smart contracts to a public blockchain, we'll be able to run the scripts and start out with some data there as well. All right, so make sure that's running. And I'm going to go ahead and start the web server so that we can just kind of make sure that everything's still working properly with our client-side application, and that'll give us a starting point for building it. So I'll say npm run start, okay? And this will open a new browser for us. And this should be on localhost port 3000. And here we go. So it's still working. All right, so I'm going to open a new tab and keep that in a separate process. Okay, clear this out. And let's first wire up Bootstrap. So I think we didn't completely do that when we set the app project up. So let's go to source index.js. And inside of here, we need to import the Bootstrap CSS. So we're using React Bootstrap. So if you pull package.json, we've got this React Bootstrap right here. This is basically going to allow us to write some React components that use Bootstrap, but we also have the Bootstrap library that's going to provide the CSS, okay? And we can import the CSS inside of this file right here. Go back to one. We'll just do it like this. We'll say, okay. So this is just a copy and paste from the Bootstrap website. This is exactly what they tell us to do. All right, so now we can see this has changed. So let's try to make sure that Bootstrap is working properly, that it's absorbing all of our styles. So I'm going to clear out all the other CSS and also clear out some of this kind of boilerplate React code. All right, so we want to keep the app. Right, we want to keep this CSS, but we want to remove index.css. All right, so we don't need that anymore. And we can delete this file. All right, take that out. Don't save. And then we don't need this logo anymore. Delete that. Don't save. Let's see here. All right, so app.test, app.js. All right, let's just inside of here create a new div. I want to make sure it has the Bootstrap styling. We'll say hello world. And I'll say this is some paragraph text. Okay, so let's take out this logo. So inside of React, we use ES6 import syntax. So this was pulling in the logo that we just deleted. So it's going to blow up if we don't take this out. Take that out. All right. And we're also going to go to this app.css file, and we're basically going to clear out all of the styles that came with it. All right, so we're going to add more styles here in a minute, but we're going to take out everything that exists presently. So what I'm trying to do basically is just remove all of the boilerplate code that came with the client-side project that we don't want to use, and just make sure that Bootstrap is wired up properly. All right, so let's go back to our browser. And yeah, this is the correct styling that I expect. This is the Bootstrap, this is Bootstrap styling. Now what I'm going to do is add a bunch of scaffolding to the project that's going to get it started fast, okay? I'm basically going to paste in some HTML and CSS that's going to act as the framework or the scaffold for our UI, okay? And I don't really want to spend a lot of time just on writing raw HTML and CSS, right? I want the focus of this to be on the blockchain part of building this project and also the React part of building this project, which are the two fundamental skills that I'm trying to teach you, right? The HTML and CSS are, less important. So I'm going to create a new scaffold inside of here like this, okay? I'm just gonna do this, all right? Boom. And then I'm going to add all the CSS that we're going to need for the entire project inside of the app.css file too, okay? And now you can get the HTML and CSS code that I just pasted in from the link in the video resources, okay? This is going to give you all the, code at this point in the project, okay? So I'll show you what this looks like after I paste it in. Go back to the browser. And here's the scaffold for our cryptocurrency exchange, okay? So basically, we're going to have a section, that's got a nav bar. We're going to give it a title. It's going to show our account up here. And then, if you go back to the preview that I just showed you, all these sections were filled out, right? We had deposits, we had orders, you can make orders, you can list all the open orders in the order book, the price chart, we've got a place to see our orders and trades and also all the trades on the exchange. So there's gonna be plenty of work to do to fill all this out. And I really wanna focus on understanding how it all integrates together rather than just, taking a bunch of time to write all this out step by step, right? So that gets us started. And I guess really quickly, I can explain like how some of this stuff works with Bootstrap, right? So, Bootstrap works by basically adding a bunch of predefined classes that give you a bunch of behavior so that you don't have to write a bunch of CSS yourself, okay? So, for example, we give this nav bar class and nav bar expanded and nav bar dark, nav BG primary. That's basically saying we want this thing here to show up that's going to be blue, and we want it to have white text and to work like a navigation. Okay, that's basically how Bootstrap works. And also we've got some of these other classes that are Bootstrap classes, like this collapse, navbar collapse. These right here are card components inside of Bootstrap. So here's an example of cards from the Bootstrap documentation. You can see these, how you can create a card with a title and some buttons, right? And so here's an example. There's all kinds of variations on this. And also you can see the nav bar that I just talked about. You go to navs and see how nav bars work. So if you want to customize your exchange, you're certainly able to do this. Here's the Bootstrap documentation if you're not familiar with how it works. But yeah, that's the basic idea. You add classes to your markup and you get a lot of CSS for free without having to write a bunch of CSS, okay? So that's an example, right? And here's the Bootstrap documentation, which I'll also link to in the video resources. And also just note that whenever you're writing CSS or adding classes to React components, you have to use class name instead of class. So you can't do this because that conflicts with React, okay? So that's if you copy and paste Bootstrap components inside of here, basically you have to update all these values. All right. So also, there is a good amount of CSS that I've written for this because, there's some, we have to lay these cards out in a really nice grid-like fashion with some predictable widths and such. So you can take a look at that if you want to inside the app.css file. you'll see a good amount of CSS Flexbox. So if you're not familiar with how Flexbox works, I'll point you to a resource on that. You can just go to W3 Schools and read more about that. So basically, Flexbox is a way to just lay things out and like you center them vertically, horizontally, and really any position that you can think of. CSS Flexbox has done a good job at coming up with ways to do that. So I'll also link to this in the video resources if you want to learn more about how to use CSS Flexbox for your own projects. Now what I'm going to do is refactor a little bit. So this source directory is going to start getting pretty crowded pretty fast if we don't make some changes. You can see we've already got smart contracts inside of here. We've got the ABIs for the smart contracts. Now what I want to do is go ahead and create a components directory because we're basically going to put all these into their own individual React components as we build out the project, and this could start getting crowded really fast. So I'm going to go ahead and put the app component in its own directory. We'll do that command line like this. I'm going to create a new directory. I'm going to say make directory, so mkdir source, and I'll say components. All right, you can see a new folder came up here, and I'll create a new file inside of there, or I'll just move actually. I'll say mv source app.js, and we'll move that to source components. All right. Now we can see that it moved. All right, let's do the same thing for app.css and also app.test.js, I guess. So we don't necessarily need the test file. I'll probably just delete it. So app.css. All right, and I'll do app.test.js. Let's just remove this. We're not really going to write too many component tests in this, so I'll just kill that. Okay. So if we go back to our browser, oops, sorry, didn't mean to do that. I saved it and it recreated the file. So kill that. So if we go back to our browser, it's probably broken. So let's take a look. Yeah, so it failed to compile. No such directory, source app.js. And it's trying to read this somewhere else. I'm going to guess inside the index.js file. Yeah, so exactly. It's trying to pull in app, and we just changed the path to app, so it broke. So let's say dot components app, see if that fixes it. All right, there we go, back in business. So all the other components that we're going to create inside of the project are going to live inside this components directory that we just created. Now let's go ahead and wire up our application to talk to the blockchain. We're going to use Web3.js very heavily in order to do this. Okay, so there's a few things we want to do. Basically, we want to get a connection to the blockchain. We want to load up our account. We want to load the smart contracts. And we want to start calling the smart contract functions. There's a lot to do, but I'll walk you through it all step by step. And at first, we're just going to do something really basic. Let's just get a basic smoke test that we can actually talk to the blockchain and read, just some information. So I'm going to do that inside this React component. I'll just do a basic test like this. We can wire up our app to the blockchain with Web3 by just following the setup instructions in the Web3.js documentation. And I'll link to this in the video resources so you can also take a look. So what we want to do is just follow this. In order to instantiate a new Web3 connection, you basically just have to say, const web3 equals new web3, like the library, and pass in a given provider from the browser, or pass in some default value that we specify. And there's some other options we could do. We're going to use an HTTP provider, not a WebSocket provider. So let me explain this. Basically, Web3 relies on this concept of an Ethereum provider that's going to give us a connection for the blockchain. And there's a lot of different ways we can get an Ethereum provider, but for our specific purpose, our provider is going to come from MetaMask, right? So MetaMask is going to be the Ethereum provider that we're going to use for this project, okay? And it's going to get injected to our browser. It's going to be talking to our local blockchain. So we'll follow this pattern almost exactly. All right, so let's go back to the project. And first what I want to do is import the Web3 library. We'll just do that like this. At the top, we'll say import. Say import Web3 from Web3. Just save this, make sure it still works. All right, and import it properly. So I'm going to check the browser every now and then, and also the server, just to see if we have any compilation issues. You'll know pretty fast if you did something wrong, because the browser will yell at you. We can already see Web3 is defined but never used. So we're going to use it. All right, so what we're going to do is use this function called component will mount in order to load our blockchain data. So what is this? Well, this is a magic function that comes with React. All right, we can see that we have called this class a React component. It extends React component. This is pulled in from the React library. So that means this is going to come with all kinds of behavior for free. All right, and specifically, component will mount is a React lifecycle method. There are lots of different lifecycle methods that are called, depending on where the component is in, its lifecycle. So basically, component will mount is just saying that this component is ready to go and we can do some data before it's loaded, before it's mounted to the DOM. So there's lots of nuances about the different lifecycle methods. You can read about them here with the React documentation. I will put this in the video resources as well. So basically, you can see here an overview and the component lifecycle. All right, so mounting. We can see all these different lifecycle functions. Sorry, I called it a method a second ago. I have problems with too many programming languages. So yeah, you can see the different nuances of each lifecycle function. And component did update, you got component will unmount, and there's lots of others that you can check out here and find out all their different behavior nuances if you want to read about this yourself. I'll leave that to you as an extra exercise. All right. So let's actually use this. Inside of here, we're going to create a new function that we're going to call within component will mount. We're going to call it load blockchain data. We'll say async load blockchain data. All right. And what we're going to do is we're going to set up Web3. And we'll also, fetch our smart contracts, load our accounts, and all kinds of stuff. But for now, we're basically just going to connect to the blockchain right now, make sure it all worked. So we're doing this in a separate function because we want it to be an async function because we want to use the async await pattern. And I don't necessarily want to just attach async to component will mount. All right, so let's do this. We'll say const web3 equals new web3, which we pulled in from here. Web3.given provider. Or let's do a default to localhost 7545. Okay. So that's exactly like what we just saw in the Web3 documentation, basically. Almost exact. All right, so now let's just log that to the console. So console log Web3. And we'll call this inside of this load blockchain data function. Or sorry, inside the component will mount function. We'll say this load blockchain data. All right. So let's just see what happened. I'm going to open the console here to see what our output is. So we got a lot of warnings from the linter. We'll fix those in a second. But yeah, we got Web3 logged to the console. So here it is. All right. So we successfully pulled in a Web3 provider. Awesome. Now let's fetch some data back from the blockchain. But before we do that, let's fix these linter issues. Okay, we'll just read it. What's it say? The href attribute requires a valid value to be accessible. Please provide a valid navigable address as the href rule. So let's do a little debugging. Basically, this is saying the href Okay, so it doesn't like this. It doesn't like href pound. So let's try this, see if it works. Let's put a slash in front of that. I'm going to clean up some of this later, but I'd rather just fix these warnings to, yeah, all right. I just don't want to see a bunch of warnings in the console every time we open it. All right, so that'll work for now. Now let's actually detect the network we're connected to. All right, so what I'm going to do is go to web3.eth.net. So web3.eth or eth or eth, depending on how you say it, .net here. And this is going to give us a function that we can call to find out what network we're connected to. So for example, MetaMask supports all these different kinds of networks. We want to get the name of the network we're connected to, all right? So that'll ensure that we are connected to the correct one. So we can see the example here, get network type. So web3 eth get network type. I'm just going to straight up copy this, all right? And I will go to our project, say console log get network type. I'll say const network. And I'm going to use the async await pattern here instead of using callback functions. So let me explain that really fast. This is an example of how you can handle a promise chain, right? You can basically say then console.log, or you could say then and pass in a function, and inside that function you could say console.log, or you could use the async await pattern, which is what I'm doing, and I'm just saying await web3.eth.net get network type, or you could just pass in a callback function here if you wanted to. So there's lots of ways to handle it, but we're going to use the async await pattern. All right, so then I'm going to say network. All right. So let's go back to our our browser. All right, network private. Awesome. So if I change networks and go to like Kovan or something, it might blow up. Let's just try it. All right, Kovan, it worked. So it's detecting network changes. That's good. Go back to our private network, okay? Next we want to do is actually fetch the account that we're connected with, okay? And if we go back to the documentation, we can see how to do that. We'll say web3.eth or eth or eth. Say get accounts, I believe is the name of the function. Yep. So web3.eth.get accounts. This is going to get all the accounts that are in our wallet that we're connected with. So we can see how it works. We say web3.eth.get accounts, and it's going to return an array. So we're going to get the first account on the list, and that's going to be the account that it's going to represent us as we're connected to the blockchain with MetaMask. Okay. So let's just copy this. All right. Paste it in here and say const account equals await. Or say accounts plural, because it's going to return an array. So web3.eth.get accounts. I'm going to take this off. I'm going to say accounts. Save that. Go back to the terminal. Or the browser, sorry. All right, so there's the accounts. And I'm actually going to change my account. So, tell you what, while we're here, let's go ahead and import one of our accounts from Ganache. I'm going to find the first account on the list, which is this. I'm going to show its key. This is the private key. Remember, this is like the password. This is sensitive data, so if you're using a real account, don't share this with anybody. And I'm going to paste it into MetaMask like this. I'm going to say import account right here. And use the private key. Paste it in. Click import. All right, so I've already done this. So the account you're trying to import is a duplicate. That's fine. So I'll click cancel. I've got it down here. See here, account 4. All right, we can see some Ether. So I also want to mention something that you might run into while you're developing smart contracts. If you ever restart Ganache, you need to reset your account in MetaMask. And I'm going to go ahead and show you how to do that. I'm going to do it now just to prevent any headaches. So I'll click let's see here, settings, advanced, and reset account. So yes. So that doesn't do anything to your account in the blockchain. All it does is clear the cache inside of MetaMask. So you might run into issues where, your account says it has the incorrect nonce value. You don't have to know what that is right now, but you'll probably run into it sometime. Just reset your account every time you restart Ganache or connect to a new network or something like that, okay? Okay, so let's refresh this, and I can see that my new account has been reflected. That's the same account that's here in Ganache. So E4CB and E4CB. All right, so that's good. We got accounts. Next, let's try to actually load the token. All right. So we're going to fetch a smart contract and log it out to the blockchain. We're going to read the token out of the ABI's directory. All right. And you're about to see why I put everything in the same directory, because we can fetch the token from this JSON file. And anytime we, migrate it, so let's say we restart Ganache or we go to a new network or something like that. We change networks or restart Ganache. This is going to know where the token is, and it's going to basically repopulate the information for us. If we didn't do that and we had like a separate project for this, every time we made a change, we would have to update this address down here. So we'll go to the very bottom. You see this address? This is going to keep changing every time we redeploy the smart contract or move to a new network or something like that. And that's going to prevent us from copy and pasting. So it's going to give us a lot of functionality for free. So I'll show you that it works. First, what I want to do is import the token from that ABI. And I should also mention, this is maybe not the best naming. This whole file actually isn't an ABI. The ABI is just contained inside of here. There's probably a better name for this. I just called it ABIs for now. So we'll import the token like this. Say token, import token from ABI's token.json. And all right, so we can't resolve that. I believe we need to go back one more. So go ... All right, there we go. Still working. And now we'll actually fetch the token from the blockchain. So how do we do that? Well, let's just kind of step through this one by one. I'm going to kill this, and I'll say const token equals just token. Let's just do that for now. Well, that's kind of dumb. Let's say console.log token. Let's just see what, got pulled in. All right, so this is, the entire JSON file. You can see the contract token, the ABI, the bytecode. So what we want to do is fetch this ABI, and we also want to fetch the address. That's what we need. So I'll show you why. If you go to Web3, let's see here. Let's find contract. So, all right, Web3 contract. So web3.eth.contract. In order to fetch the contract from the blockchain, we need two pieces of information. We need the JSON interface and the address, right? Basically, the JSON interface is going to tell us how the token works, what the functions are, what the function arguments are, what the properties of the smart contract are, all the behavior, right? And the address tells us where that is on the blockchain. You need both of these pieces of information. And both of those pieces of information are contained inside this JSON file, okay? So the ABI and the address, and we can see that the ABI is here, and the address, let's see, remove some of this stuff, is here inside the networks, right? So we basically want to dig in, find out what network we're connected to, and find the address on that specific network. So let's do that step by step. All right, so let's get the ABI. I'll just say ABI. All right, and I'll say const ABI equals token.ABI. All right, let's see that. All right, there's the ABI. Cool. And then now we want to check for the network and like all the networks that the token has properties for. So say const networks equals token.networks. Say networks. Save that. All right, so the networks, here's network ID 5777. All right, so we want to dig into this, and also we need to fetch this network ID. All right, so I'll do that in a second, but yeah, there's the networks that the smart contract's connected to. If this was deployed to multiple networks, we'd see multiple keys in here. Like if it was on the Kovan network or the main net, we'd see a key for Kovan, we'd see a key for main, and we'd see the address of that smart contract on each of those networks. So that's what's really cool is we can manage network selection like this. So if we changed different networks, we'd be able to interact with the smart contract on different networks with this same UI. All right. So let's fetch the network ID. And instead of just, belaboring the documentation, I'm just going to show you how it works. Basically, I'll say network. Let's get network ID like this. We'll say network ID is equal to await web3 eth .net, then get ID. All right. So I'm going to console log that. All right, so network ID 5777, right? That's what we're connected with. And we can see that the smart contract has data for that specific network. So what we're going to do is use this as the key to fetch out this object to get the address, all right? So let's find the token on the network. Basically, let's say the network data. Take this out. Say this would be token.networks, and let's pass in the network ID. All right, here's the network data. We can see the address. That's really what we want, okay? So that's how we fetch the token address. Let's do that. And then we'll say address. Let's just do this. All right. There we go. There's a token address on this network. So if we go to a different network, it's going to bomb. And I'm not going to do that right now, but just so you know, this will break. We'll refactor some of this later to not break, but it will break for now. All right. So I should mention this is not great code, because if this is null or undefined, it's gonna bomb. So we'll refactor this later, but that just gets us started. All right, so now we have we have an ABI and address. So console.log ABI. It's token.abi. Yep, so here's the ABI and here's the address. These are the two pieces of information we need in order to build this smart contract with Web3 and interact with it on the blockchain. Here you go, new web3.eth.contract, ABI, address. So now let's actually instantiate it. We'll do just like the documentation says. We'll say const token equals web3.eth.contract, and we'll pass in the token.abi and token.networks. Basically, just copy this, paste it in. All right, I'm gonna say console log token, and I'll kill this. All right, let's see what happened. There we go. We've got a token logged to the console. Yeah, here's the Web3 contract. We can see all of the data inside of here. This is a really huge object, but there's lots that we can do. We can actually call smart contract functions. We can, read information from the smart contract. We can sign transactions and write data to the smart contract, call its functions, just like we did in the tests in the console when we're using Truffle. So let's do that. If you saw the Web3 introduction video, I showed you how to read, the token information, like the total supply. We did that with the OMG token, right? So now what I want to do is actually read the information from this smart contract. So let's look at how to do that. We can say, let's see, methods. All right, so we'll say my contract methods, my method, and if it has any parameters, we'll pass those in, and then we'll say call, all right? And it accepts a callback function, but we're going to use the async await pattern. All right, so I'll show you how that works. So let's go inside of here, and I'm going to get the total supply of the token. So we'll say const total supply equals await token dot methods total supply. Remember, this is a function from the smart contract that we implemented when we built it. We say call. And just as a reminder, I think I talked about this in the Web3 video, the introduction, but we have call methods and we have send methods. So call methods aren't going to create transactions. They're just going to read information from the blockchain, from the smart contract itself. So we just say call. But when we're writing, transactions, we're writing data, we're creating transactions, we use send. All right. Total supply, and I'm going to log that to the console. All right, there we go. We've got the total supply for the token listed in the console. So remember, this is expressed in the token's decimal value. So it's, a million tokens or however many we created, but it's multiplied by 10 to the 18. So this is a lot more. But yeah, that gives us a smoke test for actually, wiring up this application to talk to our smart contracts. So that's a really exciting first step. All right, I'm going to end the video there today. But in the next video, we're going to start refactoring some of this, putting it in a better spot for our app, and really kind of getting set up so we can get moving fast to building out all the behavior for our application. So I'll catch you in the next video.